Many people are terrified of black holes. According to belief, black holes are gigantic bottomless pits in deep space that are invisible yet devour everything that comes near them. However, black holes are among the most mystifying things in the universe. What is the reality of black holes? How large can they get? Join us as we marvel at the universe's largest black holes. What exactly are black holes? They're some of the oddest and most fascinating objects in space. Black holes are exceedingly dense with such tremendous gravitational pull that nothing escapes their grasp. Even light cannot escape if it gets close enough. Albert Einstein predicted the existence of black holes in 1916 with his general theory of relativity, but it wasn't until 1967 that the name black hole was coined by American astronomer John Wheeler. Physical evidence of black holes happened with the first one spotted in 1971. In 2019, the collaboration behind the Event Horizon Telescope, EHT, captured the first ever image of a black hole. While the telescope was studying the event horizon, or the region past which nothing can escape from a black hole, the EHT discovered the black hole at the heart of galaxy M87. The abrupt loss of photons or light particles is seen in the image. Astronomers have identified 3 types of black holes. First is the stellar black holes, which are born by the collapse of individual stars. These black holes are relatively small but extremely dense. Here is a perspective. A stellar black hole may pack more than 3 times the mass of our Sun into the diameter of a city, resulting in a huge amount of gravitational force to pull on everything in its vicinity. The stellar black holes then absorb the dust and gas from their surrounding galaxies, which causes them to increase in size. The Milky Way galaxy contains up to 100 million stellar black holes. Another type of black hole is a supermassive black hole, which is millions or billions of times as massive as the Sun, but about the same size in diameter. Such enormous black holes are thought to lie at the centre of almost every galaxy, including the Milky Way. But there are more supermassive black holes than stellar black holes. Scientists aren't sure how such massive black holes develop, but once formed, they acquire mass from the dust and gas around them, which is abundant in the centres of galaxies, allowing them to grow even larger. The third type of black hole is the intermediate black hole, which was discovered recently when stars in a cluster collided in a chain reaction. However, many of these intermediate black holes that exist in the same location may eventually merge in the core of a galaxy to become a supermassive black hole. The outer and inner event horizons, as well as the singularity, are the 3 layers of a black hole. The border around the black hole's mouth, known as the event horizon, prevents light from passing through. Once a particle enters the event horizon, it cannot leave. Over the event horizon, gravity remains constant. The region within a black hole, the location of the object's mass or singularity, is one of the most terrifying places one may possibly be. It is this single point in space-time where the mass of the black hole is concentrated. Black holes are invisible to the naked eye, unlike stars and other celestial objects. Thus, astronomers detect them by measuring the radiations they emit. As gas and particles are pulled into the black holes, radiation is generated. Now, which of the 2 black holes is the better one to fall into? Is it the small ones or the big ones? Surprisingly, if you fell into a supermassive black hole rather than a small stellar black hole, you would likely survive for longer. This is due to the fact that tidal forces are lower near the event horizon of a supermassive black hole than they are within a smaller black hole. This implies that an unfortunate astronaut may be able to survive until they pass beyond the event horizon, whereas a smaller monster would rip them apart far sooner. Anything that falls into a black hole is stretched out into a long, thin form resembling a piece of spaghetti, a process known as spaghettification. This leads us to the list of the largest black holes ever discovered in the observable universe. Prepare to deal with difficult to understand sizes and scales. The S50014+81 is the first on our list, one of the most powerful objects in the known cosmos at 12.1 billion light-years away. This colossal beast is a distant quasar. Quasars are produced by supermassive black holes consuming matter, and it is this consumption that makes quasars or quasi-stellar radio sources the brightest objects in the known universe. As quasars consume matter, the matter it consumes spins inwards towards the central black hole. As this material approaches the singularity, it spins faster and faster, creating tremendous friction and hence heat. Finally, the heat is so intense that it emits massive amounts of light and other types of radiation, including X-rays, invisible parts of the spectrum, gamma rays, and radio waves. Quasars are so luminous and produce so much energy that they are practically incomprehensible. S50014+81 is one of the most powerful quasars ever discovered. The black hole at its heart is 10 times more massive than the black hole at the centre of our Milky Way galaxy. This black hole's Schwarzschild radius is 118 billion kilometres. The black hole in the biggest known galaxy, IC 1101, is ranked third on the list. William Herschel, a German-born British astronomer, discovered it on June 19, 1790. However, Herschel had no idea what he was looking at the time. Galaxies were still thought to be nebulae in the Milky Way. Their real nature was not confirmed until the 1920s, when Edwin Hubble used a Cepheid variable to determine the distance to the Andromeda Galaxy. IC 1101 is the brightest member of the Abell 2029 cluster of galaxies, which has a diameter of 5.8 to 8 million light-years and is one of the densest clusters in the sky. IC 1101 carries the designation A2029 BCG as the brightest member, with BCG standing for the brightest cluster galaxy. However, the IC 1101 is known to contain dying stars with minimal star formation activity, yet this does not prevent it from harbouring one of the biggest black holes known to humanity. In the centre of this huge galaxy lies a radio source known as PKS 1508+059, which emits two jets in opposite directions. The existence of the two jets indicates the presence of a supermassive black hole at the centre of the huge galaxy. The mass of the black hole at the core of IC 1101 is between 40 and 100 billion solar masses. This black hole grew in size by ejecting billions of stars from their orbits. What a cosmic bully! Astronomers believe that the core of IC 1101 is lacking around 490 billion solar masses. The Holmberg 15A black hole is the second largest supermassive black hole in the universe. About 760 million light-years away, in the middle of the Abell 85 galaxy cluster, which contains more than 500 galaxies, is the supergiant elliptical galaxy known as Holmberg 15A. A group of astronomers from Munich's University Observatory and Max Planck Institute for Extraterrestrial Physics discovered the existence of this black hole. So how big is Holmberg 15A's black hole? This monstrous black hole is the equivalent of 40 billion solar masses, or nearly 2% of the total mass of the galaxy. This black hole was most likely created by an extended sequence of galactic mergers. The current hypothesis, which is backed by several hydrodynamic simulations, predicts that when two galaxies merge, their core supermassive black holes, or SMBH for short, fall progressively towards the centre of the new galaxy formed by the merger. The two SMBHs attract each other through mutual gravity, establishing a binary system whose orbit rapidly narrows as a consequence of energy exchanges with the billions of stars that populate the new galaxy's centre. The dynamics of these gravitational interactions between stars and black holes are such that at each encounter, the two SMBHs cede a portion of their orbital energy to the stars passing nearby. As a result, the two black holes' orbits become tighter, while grazing stars are ejected at high speeds outside the galactic centre on largely radial orbits. Thus, over millions of years, the galaxy's core steadily depletes of stars, explaining the brightness deficit found in Holmberg 15A and other elliptical galaxies. The hyperluminous quasar known as TUN 618, which is 10.37 billion light-years from Earth and contains the largest black hole known to man with a mass of 66 billion times that of the Sun, holds the title of largest ever black hole. It was first discovered in 1957 while surveying faint blue stars that do not lie on the Milky Way plain. TON 618 was determined to be a quasar in 1970 by a more thorough radio study. TON 618 is thought to be an accretion disk of extremely hot gas spinning around the massive black hole at the core of the galaxy. It is so bright that it outshines the rest of the galaxy. It is one of the brightest objects in the cosmos, with the brightness of 4 10⁻40 watts, which is comparable to 140 billion times the Sun. The emission lines in the TON 618 spectrum show that the gas is moving extremely quickly, with hints of 7,000 kilometers per second speeds of infalling materials implying a very high gravitational pull. The mass of TON 618's central black hole is predicted to be at least 66 billion solar masses based on this measurement. This is one of the most massive objects ever recorded, with a mass more than the mass of all stars in the Milky Way galaxy combined, or 15,300 times more massive than Sagittarius A star, the Milky Way's central black hole. TON 618 may, in fact, fit into a suggested and new classification of ultramassive black holes due to its tremendous mass. This group of black holes has a Schwarzschild radius of 1,300 astronomical units, or around 390 billion kilometers in diameter, which is more than 40 times the distance between Neptune, the outermost planet in the solar system, and the Sun. Let us know what you think of the supermassive black holes in the comments box down below.